Good evening, all guys. Good evening, my dear students. I hope you all had a productive day and you're all ready for another powerful learning journey into big data systems. Guys, before we start, so can you please confirm if my screen is visible and my voice is clear? Great, guys. Thank you. Guys, let me begin today's session with a thoughtful that beautifully captures the essence of what Spark SQL and Spark ML lib helps us achieve. Okay, so the quote is, the goal is to turn data into information and information into insight. Guys, so this quote I've taken from Carly Fiorina. Okay, so my dear students, so this is exactly what Spark SQL and Spark ML lib are designed for. So today we will learn how to take raw big data and extract informations using Spark SQL and then convert that information into insight using machine learning algorithms in ML lib. Okay, so are you all ready for today's session, guys? So yes, guys, before I'm going to start the session, I have one interaction session with you guys. So I will take one small case study and I will discuss on that. So later on, I will jump into a Spark concept. Are you all ready now? Are you all ready now? Can I get quick confirmation on chat box? So once you people are ready, so can you all type ready on chat box? Okay, thank you guys. I got only one reply. I don't know what others are doing. Not an issue. Guys, imagine you are working for a new OTT platform. Guys, I'm going very slowly to explain this case study. So later on, I want your involvement to solve this problem. Okay. So I'm repeating, guys. Imagine you are working for a new OTT platform, something like Netflix, but made in India. Okay. Your company wants to show highly personalized movie recommendations to every user. Guys, you have millions of users, hundreds of thousands of movies, and users rating movies from 1 to 5. And metadata, you have genre of the movie, actors, release year, but not for all movies, guys. That you should remember. Guys, the challenge is, so how do we recommend the right movie to the right user? This is the challenge, guys. So what is your opinion? What is your answer? Tell me, guys, if there are millions of users and millions of movies, so will simple SQL queries be enough to give personalized recommendations? What is your answer? Is it possible by simple SQL queries, guys? That is my question. So I'm getting so many no's. Correct answers, guys. So SQL alone cannot understand patterns in user preferences. Correct, no? Are you all getting? And I have one more question to you all, guys. So which component of Spark do you think we will use? Any guess? Any guess, guys? Okay, Spark SQL. So let me see how many of them are going to give answer to this question. Okay, one more answer I got. Spark SQL. Only Spark SQL, guys. Only Spark SQL is enough. Is it enough, guys? High query. See, Spark SQL you are using. Why do you want high query? R. Okay, R you have mentioned. Correct. We can combine with Python. Okay. Guys, already I've told you the answer. So Spark SQL plus Spark machine learning library. Correct, no? Guys, as we all know, Spark SQL is used to prepare clean data and Spark MLlib to build a recommendation model. Would you agree my point, guys? Would you all agree my point? Yes or no? See, look at here. So I'm showing my slide. Guys, so see the big picture, guys. So use Spark SQL. Here we can use this Spark SQL to load and clean the data. This is first thing. And next, join user ratings with movie details. And one more is remove duplicates, missing values, so on and so forth. Correct, no? For this Spark SQL is very helpful. I'm giving you a very small solution, guys. And next, along with that, so we have to use collaborative filtering in MLlib. Correct, no? Let me write here. Collaborative filtering in MLlib. Guys, here in collaborative filtering, so we can predict rating for unseen movies. And one more is, so you can recommend top K movies to each user. Correct, no? So this is the second thing, right? So along with this, guys, along with this, you can evaluate the recommendations. So this is exactly what we will learn today, guys. So we are learning Spark SQL plus MLlib working together. Okay. Guys, again, I would like to welcome you all to session 15 of Big Data System. So today we are entering one of the most important practical parts of Spark ecosystem. Okay, so we are discussing Spark SQL, we are discussing Spark MLlib, and these are the component that transform Spark from data processing engine into a full of analytical platform. Okay, so these are the topics we are covering in today's session, guys. Okay, so we are, as I told, we are starting with Spark SQL. Under Spark SQL, we are discussing distributed SQL processing, structured or semi-structured data, and data frames. And next to that, we have Spark MLlib. Under Spark MLlib, we are discussing regression, classification, clustering, and collaborative filtering. By the end of this session, my dear students, you will be able to build a complete big data machine learning pipeline. So that assurance I can give you guys. Okay, now I'm jumping into next slide. So all of them look at here. So now let me explain each point. So here, see, I have taken 4 points, right? So in detail. So let me take the very first point, guys. So integrate SQL querying into Spark programs. Guys, I'm going to explain each and every steps in detail. So try to understand this. So this is very, very important. Okay. Guys, Spark SQL allows you to mix SQL queries with Python, Scala, or Java code. So let me take one small example to explain on this, guys. So let me take one small example here. I'm taking select and then I'm writing region, comma, some sales from transactions group by region. Guys, so this I can write, this code I can write inside Python. Okay, so we will call it as PySpark, guys. So instead of writing Python, let me write it as PySpark. So this kind of code, so I can write inside PySpark. So that's why I have explained this point here, guys. Integrate SQL querying into Spark programs. I think every one of you understood this point. And next point you can observe here. I have taken one more sub point here. Distributed SQL query engine with in-memory processing. Guys, this means SQL queries run across multiple machines in parallel. And query results stay in memory instead of writing repeatedly to disk. Guys, this is executing. This query is executed. So it is not storing back to your disk, guys. So instead of that, so it is storing value in memory concept. So this brings massive speed up compared to the Hadoop Hive concept. So one of my friend told, right, Hive query. Guys, this is the difference between Hive query and also Spark SQL. And what is the third point I'm explaining here? Guys, work with a variety of data in Hive table, JSON files, Cassandra, etc. via SQL interfaces. Listen to me carefully now. Guys, Spark SQL can read. Okay, can read from Hive table, JSON files, Cassandra, that is Paraquet, Cassandra, JDBC. Yes, I can read data from JDBC also, guys. Okay, I can read data from JDBC also, or I can use some cloud platforms like S3, Azure Blob, and along with that, I can read data from HDFS also. Okay, so this is possible with the help of that Spark SQL, guys. Okay, so guys, suppose you are including this inside your see, you are reading JSON file means. So then what you have to do, guys, you have to write df. Df is nothing but data frame. And then you have to place a keyword spark dot read dot JSON. See, I'm reading JSON format. So, and then what I have to pass here? I have to pass the name of the file here. So orders dot JSON. So this I can pass here. Understanding my point? So this is how we are going to read variety of data from different resources. Okay. So, and you can observe here, I have taken one more point here. So write your code in Python, Java, Scala, or Hive query language. Guys, you can choose any language that is left to you. Okay. Spark SQL is equally powerful in all languages. It is interesting, right? Is it not interesting, guys? And one more sub point given here. Can significantly speed up Hive query language queries with in-memory processing. That already I've explained you. Guys, Hive uses MapReduce. Correct? No. Hive uses MapReduce. That's why it is slow. But Spark SQL replaces MapReduce with in-memory DAG execution. Understanding why it is so fast. So, many queries run 10 times to 50 times faster compared to Hive. Okay. And one more point I have mentioned here. Can you read here? So JDBC, ODBC connector with Spark SQL. Okay, this means you can connect business intelligence tools like Tableau, Power BI, Superset directly to the Spark. So just like connecting to MySQL. Very simple, guys. I can connect very easily. Okay, so this is the advantage of using Spark SQL, guys. Now tell me, guys, now I would like to ask you one question to you all. Now, can you all tell me, why do you think analysts love Spark SQL? Yes, what is your answer? Hmm? Why do you think analysts love Spark SQL, guys? In-memory processing, okay. So how many of them are good at SQL here? It's really flexible, can work with multiple tools, languages, and it's really fast. Scalability, okay. How many of them are good at SQL here? Anybody is good at SQL? Yes, okay, guys. So ease of SQL plus distributed speed. So both are the reasons why analysts love Spark SQL. Yes or no? Yes or no, guys? That's the exactly why Spark SQL is so popular nowadays. Okay. Okay. Yes. So now I'm jumping into next slide. I think this slide is crystal clear, right? So I'm taking each and every point I'm explaining you guys. So now look at here. So here I've taken again. So I have jumped into data frame concept. Guys, here the very first point is saying, so data frame is distributed. See, look at here. Data frame is distributed collection of data similar to RDD, but organized into columns similar to relational tables. Okay, what do you mean by data frame, guys? Can anyone tell me? What do you mean by data frames? So data frames are nothing but structured with schema. So this is structured with schema, right? Yes or no? This is structured with schema. Okay, what do you mean by RDD? So RDD is unstructured. So example like a table in SQL. So a table like SQL. Okay. And point two, look at here. Point two, I mentioned, think of data frames in Python. So think of data frames in Python. So similar to what pandas data frames, but it is distributed. But this is completely distributed. Okay. So give me 1 minute time, guys. I'm getting a call. Continuously, I'm getting a call. Let me attend that call. So sorry guys, sorry for the inconvenience. So I got a important call. So now I continue guys. I hope my voice is audible to everyone. Is it audible? Is my voice audible to everyone? Yes. Yes, I was talking about this, right? Yeah, I was talking about data frame. Guys, so already I've told you data frame is a distributed, see here I have mentioned distributed column-based data set. Correct? No, it is a column-based data set. And it is very much similar to your relational table. And see, significantly, it is faster than an RDD. So let me explain you this very slowly, guys. So RDD, already I've told you, RDD is equals to unstructured collection. Unstructured collections, correct? No? And what about data frame? So data frame is equals to what? Structured column with a schema. So this here, in this case, queries can be optimized intelligently. That you should understand. Okay, so look at the what code here. Let me write the code now. So df equals to, I'm writing SQL context dot read dot JSON. And then inside this, I'm passing some employee JSON file. So this is what I'm passing. This automatically infers the schema and create a structured data frame. Okay, see, we have taken data in unstructured format. So once you are writing this code, so automatically it will take the data. So here that sentence is what code is here. Okay, so automatically infers the schema and create a structured data frame. Understanding, guys? So this is the beauty of using this. And see, suppose I'm talking about programmatic SQL means. See, you can go through this code. df underscore out is equal to df filter. So df region equal to Europe. Something I have mentioned here, right? Some code I have mentioned here, right? So here, what you have to notice is how clean and readable it is. And this runs on millions of rows, guys. So this runs on millions of rows. Okay. And the very, very important thing is, so before you are going to perform this, you have to register data frame as a table. To register data frame as a table, you are going to use these two lines. So df dot register template t and df2, see df3, sorry, df3 equal to SQL context SQL select star from t. Guys, this means you can write SQL queries inside your Spark program just like in databases. Just like in databases. Understanding, guys? So this is what we are going to call it as data frame. Clear? And next slide, you can see here. Guys, this slide, I'm giving you only, see, this Spark SQL part is done. So now I'm jumping into Spark MLlib part. Okay, Spark MLlib section starts here. So before this, so let me see how many of them are familiar with machine learning concept. Are you all familiar with machine learning concept, guys? Yes or no? Are you all familiar with machine learning concept? So Gautam is saying no. Okay, Ajit is also saying no. Have you not learned machine learning concept in your degree? Don't you have subject, guys? Don't you have subject on machine learning? No? Oh, then it is very difficult, guys. So I'm going to brush up the concept, guys, brush up few algorithms. So in depth, I can't teach you the concept, guys. It is a separate subject. So that's why what I'm going to do now. So first, let me start with the regression concept. Okay. So now the very first thing is you have to understand the definition of regression. So let me start from here. So I have taken this as a linear regression. So before that, we have to understand the definition of regressions, guys. Regressions are nothing but, guys, regression start with, see, regression predicts a continuous numerical values. Try to understand this. Continuous numerical values. So this regression is used to predict continuous numerical values. See, for example, you are trying to what? Predict housing prices. You are trying to predict sales. You are trying to predict temperature. So there you can use regression concept. But you can ask me, sir, how does it work? Correct? No. You will ask the question, right? How does it work? Guys, you train the model using historical data. Okay. So here, at the time of what taking historical data, so we are going to take two things, guys. The very first thing is dependent variable. We are taking dependent variable. So we are going to call it as label, and independent variable. Along with that, we are taking independent variable. Two things I'm considering here. Okay, independent variables are nothing but features. Independent variables are nothing but features. So dependent variables are nothing but label. That you should understand. Guys, in multiple linear regression. Okay, so see here I've taken multiple linear regression. In multiple linear regression, we use multiple features to predict the outcome. Not only one feature we are going to. Features are nothing but columns, guys. So in your data, means in your data set, you have a number of columns, means each column is called as a features here. So to predict the outcome, so we are going to use more than one features, means then it is called as multiple linear regression. Okay, guys, Spark ML library gives built-in algorithm to train and fit these models on huge data sets. Suppose you people are learning machine learning, means then you have to write hundreds of lines of code, guys. But in case of Spark, only the thing is you have to call the algorithm, you have to build an algorithm to train and fit these models on huge data sets. So this is the beauty of using Spark ML. So why is linear regression good? Guys, linear regression is simple, interpretable, and work well if relationship is linear. See, look at here. It is showing a graph, right? So better you all go back and learn about this linear regression, guys. Machine learning concept. Without understanding machine learning concept, you are listening to my classmates, you will be in what? Some in confusion mode. So that's why after completion of my class, you better all go through few numerical algorithm, machine learning concepts. Okay, this is about linear regressions, guys. Okay, so let me see any questions. Okay, fine. I understood. And there are so many resources, guys. You go and search in any one of the resources, you will get information on linear regression. It is very easy. Okay, so here I have mentioned, right, this is comes under supervised learning. Actually, in machine learning, we have three different types of learnings. One is supervised, unsupervised, and one more is reinforcement. Okay, so this linear regression is comes under supervised learning. The meaning of this is data has labels. Okay, data has labels. That is the meaning of this, guys. So is this clear? So now at least you got some basic idea on linear regression. Yes or no? And yeah, suppose I'm asking you one question, guys. See, you are trying to what? Predict dependent variable using features. Okay, guys. features means what and all features you are going to use to calculate, otherwise predict house prices? Can anyone tell me now? Can you name few features to predict the house price? Yes, anyone? Area, number of rooms, correct? No. Location. Why bank interest rate? Okay. Why you are taking bank interest rate? Huh? House price I'm dictating, that's it. So area, number of rooms, location, and age of the house, and number of bathrooms. Okay, correct? No. See, these are the what features we are going to use to predict house price, right? Yes or no? And I have told you one more point here. Have you observed? I have told you about here. Somewhere I've shown you that. What is that? Yeah, training data. So this training data set to learn the function. Guys, example, guys, usually, so once I'm taking any of the data set, so I will be what dividing that 100% data set into two different parts. So this, I can take any combinations here, guys. I can take 70-30 combinations, or some people will take 80-20 combinations. So 80% for training and 20% for testing. And some people will take 70% of the data set for training and 30% for the testing actually. So this is what exactly we are going to do. Okay, so by using this 70% of the data or 80% of the data, the machine start learning it. And later on, once we have done with that, then we are going to test the remaining 30% of the data by this trained model. Understanding, guys? This is what happens in machine learning concept. And here I've mentioned, right, use new data to predict outcome from features. Guys, once model is trained, so then what we have to do, guys, we have to feed a new houses features to predict the price. So that is what they have mentioned in the second point. And multiple linear regression already have explained you. So many independent variables I'll be having in multiple linear regression. Okay. And see here, can extrapolate gives it learns a function. Guys, models can predict beyond training range, but with caution. Okay, so let me take one small example to explain on this, guys. I want you people to understand this thoroughly. Okay, so suppose salary increases $1,500 per year of experience. Per year of experience. If a person employee has 5 years experience, then what is the predicted value, guys? What is the predicted value? Predicted salary increases 5 into 1,500. Correct? No, that is equals to $7,500. Am I right or wrong, guys? This easily I can predict, right, by using the existing data. Guys, now I have a question to you all. So after understanding all these things, so now I have a question to you all, guys. Is linear regression suitable for predicting whether a mail is spam or not? Yes or no? Is linear regression is suitable for predicting whether a mail is spam or not? Okay, so many people are saying yes. Guys, I think you people have not understood this linear regression concept. Guys, in linear regression, you just imagine you have a set of data. So you have it what data set? Data set is containing column 1, column 2, column 3, column 4. Suppose I have to identify some column 5 value, means this is house value, guys. So I have to take the value from C1, C2, C3, C4, and then I'm going to get this data. Understanding? That is called as linear regression. But in case of my question, guys, so we are dividing it into only two parts, right? So either it will go to spam part, otherwise it will go to not a spam part. So is it comes under linear regression? No, guys. So this is comes under classification problem. Am I right or wrong? Are you all getting my point? So this is comes under classification problem, guys. It is not comes under regression problem. That's why initially I've told you the meaning of regression. I think now you're all getting. Okay. So now, yeah. So now without making delay, I'm jumping into next model. That is non-linear regression. Under non-linear regression, I'm giving you the example of decision tree. Guys, look at here. Look at the very first point mentioned here. So divide data into subset. See here I mentioned divide data into two subsets or subsets. Guys, decision tree splits based on the questions like, so is area is greater than 1000 square feet? Is locality premium? Understanding my point, guys? Understanding my point? So decision tree splits based on the few questions. Okay, based on that, it will what? Increases the purity of each split. Am I right or wrong? See, example is mentioned here. 50 to 20 features determines price of a house. So house price is depending on many nonlinear interactions. Many nonlinear interactions. And look at here. Predict price of house given a set of values for features. Guys, average of training samples in the leaf will give you the what correct answer. It is going to what predict the correct answer. Then how split point is determined, guys. So to determine this split point, we are going to use this MSE concept. MSE is nothing but mean squared error concept. Go and search in at Google. You will get it. And it cannot predict if test data is very different from training data. Guys, if the test data differs drastically, trees struggles, guys. That is what I would like to say here. So let me take one small example to explain on this. Okay. So imagine rooms are greater than or equal to 3. Then so distance to city center is less than or equal to 10 kilometers. So these are the two conditions I have used here. So this is different price groups. How many of them will agree with my point? Yes or no? Is it not yields to different price groups? Huh? Nobody is answering on chat box. Are you all there, guys? Are you all there? You all understood what is the second one? Non-linear regression decision tree. Guys, linear regression assumes a straight line relationship that you have seen in the graph, right? But in reality, data is rarely linear. Okay, so decision tree regression solve this by dividing data into subset, creating a tree structure, and choosing a split point that minimize mean squared error. So example I've taken. So house price predictions based on 50 to 20 features. So based on locality, area, number of rooms, age of building, etc. So decision tree makes splits like area greater than 1000 square feet. Locality is equal to premium. See, until the information gain becomes low, this will be what keep on going. And here we have a drawbacks, guys. The drawback of this decision tree is it cannot generalize well if test data is very different. I hope everyone will agree with my point. Correct? No? So now this is about non-linear. Now I'm jumping into the third methodology that is called as ensemble techniques. Dear students, ensemble, what is the meaning of ensemble? So ensemble is nothing but multiple models combined. Okay. So the meaning of this is multiple models combined. This is the meaning of ensemble technique. Okay. So under this, we have two major techniques, guys. So the very first technique is called as boosting technique and second technique is called as bagging technique. So what do you mean by boosting? Guys, boosting build a sequence of weak models. See, look at here. Use multiple weaker learners and build a stronger learner where each learner can take input from a previous model to improve further. The meaning of this is, guys, we are building this boosting model by using a sequence of weak models and each model improves on previous mistakes. So the best example for this is GBR, that is gradient boost regressor. So this is built on decision tree. Okay, this is built on decision tree. So this is boosting methodology, guys. And one more we have that is called as bagging. Guys, look at the points given here. Take random samples of the data set for each model. So in this case, we build many models independently, not dependently, and use random subset of what data and features. The best example for this is random forest algorithm. Okay, so why do we use ensemble? Because they reduce bias, variance, and overfitting. That is the main reason. So why we are going to use ensemble methodology, guys. So hope everyone understood what exactly the meaning of ensemble. Yes or no, guys? Yes or no? You all with me? Hmm? Are you all with me, guys? So what are the two techniques comes under ensemble techniques? One is boosting. As I told, this builds weak learner sequentially and each model focuses on previous error. The best example for this is gradient booster regressor. Okay, so usually in this GBR, it will take the previous mistakes and then it will correct it. So that is boosting concept. Whatever was bagging, guys. So it is built multiple trace using random subset. So and then it will take the average predictions. It will reduces the what overfitting. The best example for this is random forest algorithm. Okay, so as I told, guys, it will removes bias. So using different samples plus feature what ensures fairness. Okay, let me take one small mini concept to explain on this, guys. Okay, if one tree predicts, okay, if one tree predicts, let me take in rupees, guys, instead of what dollars, I'm taking in rupees. So if one tree predict 55 lakh and another tree predict 50 lakhs. Okay, let me take 50 lakhs. And another tree predict rupees 52 lakhs. So what a random forest is going to do, guys? Can anyone answer? After understanding this, what random forest is going to predict? See, randomly I picked, right, models. So one is showing 50 lakhs, another one is showing 55 lakhs, another one is showing 52 lakhs. So average, right? Random forest predicts average. That is nearly equal to what? 52 point something. 52 point something. Am I right or wrong, guys? So that is random forest. Guys, which method produces a stronger final model? Boosting or bagging? What is your answer? Yes, correct. Your answer is correct. So which method produces a stronger final model, guys? Boosting or bagging? What is your answer? Boosting, right? Because boosting focuses harder on mistakes. So that's why boosting is the best methodology. And next, guys, that's it about ensemble learning. Now I'm jumping into the next methodology that is called as clustering. Okay. So this is classification. Yeah, not clustering. Before clustering, I will jump into classification methodology. Okay, guys, this classification comes under supervised learning approach. I told you, right, in ML we have different types. So here, look at here. So this comes under supervised learning, linear regression. So even this is also comes under supervised learning approach. So as I told, data labeled here is with categories. Understanding my point, guys? So as usual, guys, here also we have a second point. Train a classifier with labeled data. Okay, so train classifier with input features and label value. So example for this is email features. So for email, so what I'm going to do, guys, either I'm going to name it as spam or not as spam. Okay, so after that, what we are doing, test the model on a what? New data set, not on the existing data set. So we are testing this with new value. So this will always predict class. So this will always predict class. What class here, guys? Spam or not a spam is the class here. Okay. And look at here, similar algorithms as regression. So here also we are going to use logistic regression, decision tree algorithm, random forest algorithm. Okay. So it is very much similar to regression concept, guys. Okay. So look at the example given here. So look at the example given here. What is this example? Guys, this is on wine quality. Guys, wine quality is measured by a set of features, attributes, right? So we are going to take alcohol content, acidity level, and what is given here? Sweetness of the alcohol and fermentations. We are going to consider fermentations. So that is the outcome, good or bad. Okay. See, all these features we are going to consider in this example. Okay. So let me take one small example to explain on this, guys. So for classification algorithm, guys, suppose you are going for bank loan. Okay. You are going for bank loan. Now, for bank loan, they will check your salary. They will check your credit score. Then they will check age and employment type. Employment type, correct? No? So based on this, they will classify whether we have to approve loan or disapprove. Correct? No? Approve and disapprove. See here, approve and disapprove comes under classification. The meaning of this is loan approved or loan rejected. Correct? No? This is the best example for classifications, guys. So now I have a question to you all, guys. So once after explaining this, I have a question to you all, guys. What is the output of classification model? What is the output of category means classification model, guys? Huh? Either it would be what category or it would be not Boolean answers. So yes or no. Okay, yeah, maybe yes, I can consider this also, yes or no, approved or non-approved. So this is called as what, guys? Category, or we can call it as class. Okay, your answer is perfectly correct. I think everyone understood what do you mean by classification. Next, we have the next methodology, we have clustering. Look at here, guys. Next, I'm trying to explain clustering concept now. Okay, so clustering means what, guys? See, clustering is comes under unsupervised learning, unsupervised machine learning concept. So unsupervised is nothing but no labels, guys. So in supervised, we have used labels, right? So in unsupervised, we are not going to use any labels. Okay, no labels. So here we will discover patterns. We will discover patterns. Understanding my point, guys? Then look at the second point, group set of items into clusters. Guys, what we are going to do here, so we are going to take similar items and then, so all the similar items, we are going to group it into cluster. So that's why they have mentioned here, group a set of items into cluster. Okay. And one more point. Why is not data labeled? Guys, the reason behind this is it is too expensive. And sometime it would be what comes under unknown category. And sometime we will be having what too many items. So in that situation, so the people are not going to what concentrate on labeling. They will be what focusing on unlabeled thing. Correct? No. So in that case, guys, see, look at here. We have mentioned here. So can include clustering to a labeled data as a part of classification process. So we can use in classification. See, in classification, the very first thing is we have to cluster the data. So we have to cluster the data, and later on after clustering, so you can label it. You can label it. Understanding my point, guys? So let me take one small example to explain on this. See, look at here. I've taken the example of spam filter, or we can call it as spam detections. Guys, cluster email by similarity. You take all the emails. So similar emails. So first we have to collect all the similar emails, right? That is called as a cluster. And ask user to label cluster as spam or not a spam. Understanding? So you're clustering it first and then you're labeling it. Okay. And one more example they have given here, fake news detections. So first you have to collect all the fake news, and later on you can label it. So hope everyone understood what is clustering concept. So now my question is to each and everyone. So is clustering used for prediction? What is your answer? I have given answer at the very beginning, guys. Now my question is clustering used for prediction? What is your answer? No, right? See, cluster is used for what, guys? Cluster is used for pattern. Correct? No. No, clustering is not used to help label data. Okay, so it is used for pattern. That definition I've told you at the beginning. But still, I'm not getting correct answers, guys. Maybe yes, the topic is not familiar with you people. That's why you people are not giving correct answer to me. Am I right? Yes or no, guys? What you have understood in clustering? What did you understand in clustering, guys? So clustering, group of items based on similarity. And since we have what many data sets are unlabeled, we are using this cluster. The best example for this is market segmentation, search result grouping, and social media post grouping, spam detections. So see, these are the applications. So we can use clusters, and clusters helps to create labels that can later be used in classification. Okay, so all this concept we have learned in clustering concept. So now we are jumping into one more very important concept. So in machine learning, that is called as k-means clustering method. Guys, listen to me carefully, everyone. So once you don't know about k-means clustering, so whatever the information I'm giving you, this is enough. So K, so here we are taking K, right? So K means, see guys, this K means algorithm is the most popular clustering algorithm. So here we are going to follow few steps, guys. I will tell you steps one by one. Okay, try to understand this. So the very first step is, so we are going to pick K cluster center. K cluster center. This is the very first step we are going to follow here. And second step is assign point to nearest center. See, look at here. This is the data set. Okay, as I told, so here we are choosing center first. So K center we are identifying here. So after identifying K centers, we are calculating distance from one point, means center to other center, so other points actually. Okay, so by calculating this, we will get to know so which one is very close to that particular center. Correct? No, that is the second step we are doing actually. And third step, so we'll be what keep on computing the same thing. So we'll recompute centers. So after what getting some centers, again I'm going to what recompute. So this is repeated task we are going to follow in machine learning. And finally, still I get stable. Stable is what here? Convergence, right? So still I get convergence. So I'll be what keep on reconstructing the center. So guys, and one more very important thing is this distance calculations runs in parallel. Since it is runs in parallel, so this is most suitable algorithm for Spark actually. So this is a perfect algorithm for what? Spark, guys. So how to evaluate this cluster, guys? Guys, here we are going to use one methodology. That methodology is called as Silhouette score. Listen to me, everyone here. Silhouette score. So Silhouette score means low means tightly coupled cluster found. So lower intra-cluster distance we are calculating here. So this lower intra-cluster distance will be always giving you the better cluster with the help of the Silhouette score actually. And look at here, guys, I'm talking about predictions also here. So once centers are learned, so new data points are assigned to closest cluster. Understanding my point? Guys, Spark not only support this, so along with that, Spark is supporting for Gaussian mixture model to calculate what distance. And we have power iteration clustering methodology and many more, guys. So it is not only two, it is not only three. So we have many more algorithm to calculate this distance in Spark. So that's why what I would like to suggest here is, so Spark is the best. Okay, K-means is the best algorithm to use in Spark concept. Already I've given you the reason, right? Why it is already I've given you the reason. So this is the main reason. So why we are using it in Spark concept, since it is calculating distance parallelly. So we are using it in Spark concept. I hope this is crystal clear to everyone. K-means algorithm. Guys, I'm not giving you depth idea on each and every concept, guys. I'm giving you only layered explanation on each and every concept. So this layered approach will give you the understanding of what each and every methodology clearly. I hope this is clear to everyone. Is this clear to everyone? So what you have to remember? You have to remember iterative, choose centroids. So that is the first point. And then we are going to perform distance computations in parallel. And then we are going to use Silhouette score to measure clusters tightness. And we are going to predict cluster labels. See, once everything is done, means, so we assign cluster labels based on nearest centroid. And these are the other methodology we are going to use here. One is GMM, so Gaussian mixture model. And one more is PIC. And we have so many, guys. So this is about the second model. Guys, cluster customers into high value, medium value, and low value. That is one best example for this K-means clustering methodology. Okay. I hope this is clear to everyone. If you have any doubt on this, you can ask me, guys. Otherwise, I will move to the next algorithm. Shall I move forward? Sorry, guys. Sorry. I'm getting hiccups. Okay. So now this is done, means I'm jumping into next methodology that is called as recommendation systems. Guys, now comes an exciting real world ML application that is called as recommendation systems. Okay, so example for this is we have Netflix movie suggestions, Amazon shopping suggestions, and Spotify song suggestions. Correct? Now we have so many. And under this, we have two major types, guys. So one is called as content-based filtering, and another one is called as collaborative filtering. Okay, so this content-based filtering, see, this is based on item attributes. Okay, it is based on item attributes. So I will take genre of the movie, actor of the movie, director of the movie. Understanding my point, guys? And we have one more that is called as collaborative filtering. So collaborative filtering means it is based on user behavior. So here we are considering user interaction behavior. So if user A and user B have similar taste, so suggest B's liked items to A. Okay, it is a kind of what hybrid, guys. So best of both will be what considered in collaborative filtering. So I think everyone are understanding this point, right? See, here I have mentioned a hybrid approach is better because collaborative filtering has a cold start issue. So enough user interactions have to be there for recommendations. So this is recommendation system. And next to this, we have a collaborative filtering. So I have told you just now about collaborative filtering, right? So this is the, guys, listen to me, everyone. This is the ML backbone of modern recommendation engine. Okay, so under this, we are going to use two approaches. So one is called as user-based approach. Okay, and second one is called as, let me write here, user-based approach, and another one is item-based approach. User-based and also item-based approach. User-based approach is nothing but what, guys? if two users rate similar items similarly. So then we are going to say they are similar. Understanding my point? So that is user based. So then what do you mean by item based? So two items are similar if same user liked both. Then it is concerned item based. But nearest neighbor methods fails with sparse data. That you should remember. Sparse data means what, guys? Suppose sometime we have not entered data in the data set means. So then it is called as sparse, right? Otherwise, more number of zeros we have entered means then it is called as sparse. So in that situation, so in case of what it's sparse data, nearest neighbor methods fails. That you should understand. Clear? And so, guys, Spark users. So Spark users matrix factorization. Matrix factorization. Okay, so that is in usually we are going to call it as ALS. ALS is nothing but what? Alternating least squares. Guys, this matrix factorization captures unobserved learned features like style of movie, mood of music, type of writing, so on and so forth. So these hidden taste helps to make excellent recommendations, guys. Okay, excellent recommendations. And this collaborative filtering is comes under again unsupervised learning technique. Are you all getting my point, guys? So this is about the very first part of your concept. And here I'm explaining you what nearest neighbor approach also. See, look at here, everyone. So nearest neighbor approach also I'm explaining you here. So before that, what you have to understand here is collaborative filtering is very, very important. Correct? No. Collaborative filtering. Anybody is having any doubt on collaborative filtering? So are you all understanding, guys? Otherwise, am I boring you? I'm not getting any responses in chat box. Am I boring you guys? So how about my class? Is it going good? Am I making sense to each and every concept? So if I'm making sense to each and every concept, can you all type MS and chat box quickly? So how many of them understood collaborative filtering? So everyone understood. Should I dig deeper into collaborative filtering? Since I've told it is a heart of most recommendation engine, right? Should I dig deep into collaborative learning, collaborative filtering, sorry? Yes, Ravi Kumar, I can understand. That's why I'm going very slow. That's why I'm going very slow. So no need to worry, guys. You just understand the what upper layer of each and every algorithms, guys. So you take your data set and you apply the same thing on your Spark. Guys, you have to call only one function. That's it. You should understand how to write a line of code. So in Spark concept. So that will give you what a very good what output, guys. Immediately you are going to get a faster result. That is the benefit of using Spark. Okay. Okay, guys, as I told, what is CF? Collaborative filtering. Collaborative filtering is like asking friends for suggestions, guys. If you have friend A and you like similar movies, so movies liked by A, but not you are good candidates to recommend. So key point here is collaborative filtering uses user item interactions, no item attributes. But you can ask me, sir, why collaborative filtering? Guys, collaborative filtering, see, the reason behind this is, see, suppose I have told you about what items attributes, right? Genre, director. So this may be what missing, or sometime it is incomplete, sometime it is insufficient. So here in this case, CF leverages behavioral pattern, so which are often more predictive. Guys, quick show of what? Hands. So who has seen a suggestion on Netflix that was surprisingly accurate? Huh? Type yes or no, guys, on chat box. Who has seen a suggestion on Netflix that was surprisingly accurate? I'm getting so many yes. Good, guys. So that's collaborative filtering under the hood working well, guys. Okay. So I think everyone understood, right, what is collaborative filtering. So now I'm moving bit deeper to explain collaborative filtering. Under that, I have told you, right? So nearest neighbor approach. Guys, look at here. Now let's examine nearest neighbor approach. So in short form, we are going to call it as NN. So they are intuitive and easy to implement, guys. So we have a two variant with respect to this nearest neighbor. The very first one, already I've told you, right? The very first one is called as user based and second one is called as item based. So look at here, user based means find users similar to the active user, then aggregate their item preferences. So that is user based actually. Then what about item based? Find items similar to the items under considerations based on ratings from many users. Ratings from many users. Guys, how similarity is computed? Guys, you are going to use cosine similarity, Pearson correlation, or adjusted cosine methodology. See, for example, cosine. Let me take cosine. So in cosine, what you are going to do, guys? So you are going to use similarity. Let me write here. Similarity. And then you are going to pass some formula is there. Summation R of user interface into R of VI, that divided by square root of uh, summation R underscore UI square into, so let me close this, into square root of summation of R underscore VI square. So this is the one formula we are going to use, guys. So to calculate similarity, to compute similarity, one formula we are going to use. You just go and search in the network, internet, you will get it. Suppose you just imagine, suppose we have 3 users and 3 movie with ratings. Okay, let me take one small example to explain on this. So let me write movie here. So I'm writing movie. So movie, I'm taking 3 movies. So M1, M2 and M3. 3 movies I'm taking. So here I'm taking 3 users. So one is I'm taking Alice. Another one I'm taking Bob. Another one I'm taking Carol. So 3 users I've taken here. You're all understanding. 3 users I've taken here. And here what I'm doing, I'm writing ratings here. So for M1, Alice has given 5, Bob has given 4, and Carol has given 2. And for M2, 4, 5, and 2. Say I'm taking some random values, guys. So here he has not put anything. So here I have 2 and here I have 1. Okay. So here my question is active user. See, let me take active user now. So active user is equal to Alice. Okay. So we want to predict Alice rating for M3. Correct? No, we have to find Alice rate for M3. Then what we have to do, guys? So we have to compute similarity of Alice, Bob. And along with that, so we are going to calculate similarity of Alice, Carol. So this we are going to calculate by using cosine. Okay. Guys, use weighted average of Bob and Carol rating for M3. Okay. So that is weighted by what? Similarity. So you do the math, guys. So if Bob is more similar to Alice than Carol, so Bob rating influences the predictions more. Okay, guys. So what are two immediate problems you can see with nearest neighborhood methods on large data sets? That is scalability or sparsity, right? So we cannot compute pairwise similarities across millions of users or millions of items cheaply. Also, many users rate only a few items. That will causing what? Sparsity. Okay, this is very, very important point you have to remember at the time of what understanding this, guys. So challenge that matrix factorization addresses actually. This challenge is addressed by the matrix factorization concept. Okay, so here I'm showing you matrix factorizations also. You all can observe here. Okay, that's exactly what challenge that matrix factorization addresses, guys. So I'm talking about matrix factorization approach also here. My dear programmers, now the magic matrix factorization. In short form, we are going to call it as MF. Guys, the main motivation for this is, guys, NN method becomes infeasible to scale and with sparse data. Suppose we have plenty of sparse data and it is infeasible at scale means, so then we cannot use this. That is one reason. And one more thing is, guys, that MF, this matrix factorization reduces dimensionality. So it finds latent features. Okay, not necessarily explicit attributes, guys. Okay, this explains patterns in the user item matrix. Okay, this is the main reason why we have to go with MF. And the core idea behind this is, guys, represent the user item ratings matrix R. Okay, so let me take matrix R. And the size of this is m cross n matrix. So what I'm doing here, representing user item rating matrix R approximately as the product of two lower dimensional matrices. So then what is R? R is nearly equal to U comma V to the power of T. Transform. I'm taken transform here. What is U here? So U is user into K latent feature matrix. And V is, here I've taken user. So V is nothing but what? Item into K latent feature matrix. So here I've taken item, here I've taken user. Okay. So this K value I've told you just now, right? So let me write here. So this K would be always less than or equal to M cross N. This M cross N I'm talking about. So then let me take K is equal to 10, 50. Like this, I have to take the value. So this could be always what? Less than M and N value. This you should understand. Guys, each user U has latent vector. See, here I'm talking about U, right? So each user U has latent vector UK that belongs to R. So R is nothing but what? This matrix, guys. And what about V? So this VK, sorry, VI instead of K, let me, sorry, this is U, and this is UI. Okay, so each item I as a latent vector VI, this belongs to R only. And guys, here the predicted value is represented by using R tau. That would be UU transform VI. Okay. So why do we prefer a low K here? So what happens if K is equal to minimum of M and N? So once the minimum value is M and N, so then we are going to get overfitting problem, higher complexity problem, and low K generalizations better and is computationally lighter. Then you can ask me, guys, what are the additional readings I have given here? So better you all go through this links, guys. Then you'll get some additional idea on each and every algorithms. So collaborative filtering, everything I've taken few links here. So I want you people to go with all these links, guys. Otherwise, you will never ever understand this concept actually. I want each and everyone to understand at least minimum concept in this machine learning concept. Okay. So you all can observe here. So here what I've taken. See, there are few problems with respect to NN and why MF helps. Guys, recap the problems and MF benefits succinctly. So problem with NN approach is what, guys? Scalability and sparsity, right? So scalability means, so computing similarity will be always expensive. Am I right or wrong? Computing similarity, how much time similarity will take, guys? Guys, we need big O of n square time or big O of m square time. Correct? No. So this is more expensive scalability. And what about sparsity? Guys, many missing entries make similarity unreliable. This is the problems with NN approach. Then why we have to use MF approach? Guys, MF approach, the very first reason is it will compact representation. Okay. So see, the meaning of this is store this K value. Here I have mentioned K, right? Store this K value features per user per item, not billions of pairwise similarities. And the second thing is we have to handle sparsity carefully. Guys, here I have mentioned, so learn latent structure from available ratings. That is very, very important. And third thing is you have to predict unseen interest in MF actually. So that is by computing dot product in latent space actually. Guys, let me take one analogy to explain this, guys. Think of MF as a compressing a huge image into a small set of basis images. Here I'm talking about huge image, right? Thus that huge image is called as rating matrix. And the small set of basis images are nothing but latent factors. So along with that, we are taking coefficients, then constructing appropriate pixels are nothing but predicted ratings actually. Okay. So this is the concept about MF, guys. And once I'm talking about MF implementation, so there is so many information we have, guys. So better, I would like to recommend you people to go with all these links to understand each and every concept in detail. Okay. And what about pros and cons of MF? So the main advantage of using this is, already I've told you. So this is used to scale to large data sets. And this is robust to sparsity. And this produces compact user item factors for fast predictions. And disadvantages with respect to this is cold start. Still an issue for brand new user or brand new items. Because of no interactions, guys. And algorithmic choice is also very, very difficult here. So algorithmic choices need tuning here. Okay. And that's all about this concept, guys. I don't want to drag more on this. So this will complete your 15 session concept. Next session, we have more concept on Spark that we will discuss in the next coming class, guys. I have only minimum number of slides here. Only 20 number of slides we have here. So that's all about today's session. So I want you people to learn more and more about all these algorithms, guys. So next we are concluding our 16 sessions by learning Spark Part 4. So there we are discussing more about data frames, data set, Spark SQL optimization, streaming and structured streaming, advanced ML topics, and productizations. So before that, you people go through with some algorithms, guys. Okay. So I want you people to implement a small ALS pipeline on the movie lens data set. Okay, you try to work on this. Okay, this is one homework I'm giving to you all, guys. You just go through this homework problem, then definitely you will come out with ALS algorithm. I have seen less participations today. If you have any questions, you can ask me, guys. KLS algorithms, not KLS algorithm. I'm talking about ALS algorithm. Just now I've taught you ALS algorithm, right? Guys, actually, why I'm telling you about ALS means, so ALU is efficient and parallelizable. That is one reason. The meaning of this is each step is linear least squares problem. And this works well on large sparse matrices. Suppose, see, you know sparse matrices, right? So instead of more than what integer value, you have more zeros in your matrix means there it will play a what crucial role actually. Okay, so each update is embarrassingly what parallel across users or items. So you go through that algorithm, guys, then you will understand. I want you people to go with that. I don't want to explain each and everything now only. Okay, I have given one small problem, right? You go through that. Okay. Okay. So we had only 20 slides, guys. Even next session also we have less number of slides. So I have only 40 slides. That is very much theoretical concept. So this we can discuss in the next coming class. Okay. Yes, that's all for today's session, guys. Okay, so I'm getting so many images on chat box. Guys, regarding this, HBase, it is open, right? So after that, it is not working. Am I right? HBase shell you have opened. So once you have opened with HBase, it is showing. Okay, so status, it is not working. So have you Googled? Have you Googled this problem? Ravi Kumar, I have told you many times, it is individual project. Okay, part B is completely individual project. So as I told you, have to take problem from your company or organization. Then you have to use any 3 tools, minimum of 3 tools you have to use to complete the project. No, you take any problem and solve by using big data. Correct? No. See, in every field, we are going to get huge amount of data. So either we are going to get structured data or unstructured data or semi-structured data. You're not getting data from your company. You use any three tools. See, here it is supporting for structured data, and it is also supporting for unstructured data. You take any one problem from your organization and solve it. Ravi Kumar, please. We have tools like Azure Data, Synapse Data Lake, etc. So have you learned that in your big data systems course? Yes, Ravi Kumar.
Yeah, thank you, sir. What I meant is in big data, like in the course we have learned the Hadoop ecosystem, right? So, but they like within organization we are not using those Hadoops tools and all, but instead the other tools, like I said, mostly cloud based and all. So that's where I was asking, can we take reference of those, or it is mandatory that we have to find the
But how did you show that code? Is it possible? Can you take the snapshot of each and every code and paste it on report?
No,
Will
code
they
and
allow?
all we cannot. No.
Then
No, but even it is a Hadoop, then how a code snapshot is allowed? That's
not only
that's
I'm
the
talking
point.
about Hadoop. We have other than Hadoop also, right?
Hmm. Yes.
Hmm.
So as a part of deliverables in part B, like one of the section where it is mentioned that okay we have to share the screenshot also of the code and all. So the point what I'm making is code is again it's a critical confidential thing that we cannot put even into the internal or customer related anything. So how can we look into? I mean that part of how we can take it.
You can take snapshots, right? Snapshot also not possible.
No, no, no. It's see for any for either it is a internal organization or either it is a customer. Screenshot, taking code out of it is not allowed. It's a compliance issue.
No, you take one small problem from your organization and use the use the tools available in our what BDS class and solve it.
Yes. Okay. Now this is something that's what I wanted to understand that. Okay. Now you are saying if I take the problem and then I solve it on the BDS class.
Yes,
All right.
that's it.
Okay, sir.
Okay.
Yeah, in addition to that, Ravi, basically what I got it from the assignment, we need to take our current project, our current systems in our organization, and see get the scopes to implement the Hadoop system in that to improve the performance. So this is the requirement basically. Whatever the things we are doing in our system, and if we can think of to apply the Hadoop concept to improve the performance, that's something I got it. This is something we want to show in that assignment.
Correct. Ajit, did you get that HBase part?
Yes, it's I'm able to run it on my Linux systems in Office.
Actually, many of them are asking the same question in chat box.
Yeah, I think there is some settings in a lab machines. There is some issue in the settings.
Correct.
It's not working in the lab machines.
Yeah. So some file is deleted, right? Some configuration is not matching. So because
Yes,
of
yes.
that, we are getting errors in HBase.
Yeah.
So we both worked together and finally we did not get that result. Correct, no?
Yeah. H-base cell is not coming up. It's coming up, but if you try that status command, that's not working. Means it's complaining about the zookeeper settings.
Hmm.
Yes,
Yeah.
right. Zookeeper.
So
Yuvraj
one
is
solution,
saying, Yuvraj,
once
Yuvraj, yes, Yuvraj. Yuvraj, are you there?
Yes, I'm there.
Yes, Yuvraj, you're saying something.
Yeah, yeah.
You're
So what
testing
I'm
something.
trying to come at is I'm part of a legacy product that way, which is around C++ and it doesn't involve big data related tools and setup that way. So bringing up a big data use case there and then solving it would be
No,
difficult.
Yuvraj, can't you take one problem statement which is solvable in BDS? Can't you find a single problem in your company that uses big data system? Yuvraj?
Yeah, doesn't look like that way, sir.
Even I am not looking for your company project, guys. You take one small problem. See, it is a kind of thing, guys. You have learnt BDS, and in future,
Mhm.
so after solving this problem, in future you are going to approach to your company, sir. This problem we can solve by using BDS. That's it. That is what my expectation in situated learning. Have you understood, Yuvraj?
Yeah,
What I'm
yeah, I
trying
have.
to conveying you. You take one
Yes.
small problem. You
Hmm.
take a small data set. You define a problem and then you show them. So this problem I can solve by using this BDS environment. That is my expectation. That's it. You're all understanding the outcome of this, right? So why I'm expecting this? I think you people are understanding. So why we have introduced this? Yuvraj, can you reply?
Yeah, yeah, I understand your point, sir.
Hmm. See why it is not group project means so see in a group the four-person or belongs to a different company means then we can take what individual problem. So once the students are not what belongs to any technical background means then they can go for group project actually. That I have told you in the previous discussion, right? Yeah, Tanya, just now I've addressed your problem only. Tanya, can you unmute?
Yes, sir.
Yes, Tanya. Just now I've addressed your problem. So once the people are not belongs to technical background means then you can go for group projects. Not an issue. Okay.
Actually, so while submitting, they have mentioned a clause in that part B.
No, this I have told you long back, right?
Yes, so that's
I
why we're
only
getting that, note kind of a thing. This should be individual, something like that. So that's why.
or else you take a what problem statement from your what one of the teammate and try to solve it. So don't give me
Okay.
any recommendation later. That's it. Very simple. You take any problem and solve it individually. This is clear, Tanya.
Yes, sir.
Hmm. So anything else, guys? So you people have
so
left with only one session, that is 16th session. So after that, you'll be having examinations. So start preparing for the examinations, guys.
Sir, Monish here. So, is it possible to get some more time for the to submit the assignment? Some 2 3 days more, or till
Monish,
next weekend?
Monish, 2 3 days. See, single day is not at all possible. Because
Oh,
see, in bits before 15th session, we have to submit assignment marks. That EC1 marks we have to submit. So already we have
okay.
done with 15th session. So we have left with only 16th session. Before that, so we have to what finalize all EC1 marks before your examinations. Okay,
Okay.
so we
I
have to
got
go
it.
with evaluation process. Correct,
Yeah,
no?
actually, why I'm saying because I'm left with part B only, and I'm literally not able to start the part B because the thing is I'm working in a bank actually, and
Mm.
in the bank it is not at all allowed to discuss anything which is internal, right? So I cannot even talk on this call about any problem that my bank is facing actually. Okay, so I have to have pick some other topic outside the bank actually.
Okay.
That is a problem basically. Yeah. So in that case, what should I do? Can you please suggest?
See, in that case, I've told you, right? You go with your group.
Okay.
Just now, I've told the same thing with Tanya. You take
Okay.
one problem statement from your group mate and you solve it and submit it individually. Okay.
Okay. Okay. Okay, sir. Thank you.
Sir,
Okay.
one more thing on the submission.
Yes, sir.
We just go to log in there in the portal and upload the zips and documents. This is the process.
Yes, process I have given you in the assignment sheet, right?
Okay. Okay.
So what you have to do, you have to see for part A, only one member has to submit the assignment. For part B, so you have to collect all four PDF and merge it with part A and then submit. See, any one has to what submit the assignment. That's it. Not all.
Okay. So what
So
do
you
you
merge
mean
all the documents and submit in the assignment.
what do you mean by four PDF? It's only one PDF for part A and one PDF for part B.
No, part A, suppose four different people are solving four different problems. Then you are going to get four different PDFs, right?
But it's a group project.
No, part B I'm talking about. Part B is individual project, right?
Yeah, part B, four. I can understand part B
Four.
is the four. Part A is the only one PDF.
Part A is only one, that's it.
And that
So
should
part
have the
A,
tab.
one copy, part B, four copies. You merge all the documents and you name, as I mentioned in the sheet, and then upload it.
Okay. Okay. Thank
So
you.
one has to upload, that's it. Not all four members.
Okay. Thank you,
Clear?
sir. Yeah.
Yes.
Yeah.
Thank you. So that's all from my end, guys. So if we have done with all means, then we can wind up today's session. So if you have anything to discuss, you can discuss. Otherwise, we can wind up the session.
Sir, I have last question, sir. As you mentioned, those for whom it's not applicable to get a case from a working domain, so they
Hmm.
can go with the group approach for Part B, I believe. So in that case, if both the Part A and Part B coming out as a group submission, so only one person can upload, right? Overall.
Now, for
Uh,
all, one person has to upload. See, in whatever case it is. So only one
okay,
person has
okay,
to
sir.
upload the assignment.
Okay,
So
sir.
one
Got
of
it.
your group member has to upload the assignment. That's it.
Okay, sir. Yeah.
Okay.
Thank you, sir. Yeah.
So even whether it is a group project or individual project, you see
Mm-hmm.
individual project means you'll get four copy plus one copy. So you merge
Mm-hmm.
all and the name
Mm-hmm.
they mentioned and submit it.
It's clear now, sir. Thank you.
Okay, in case of part B done in a group, there will be two documents, is what you're trying to comment effectively.
Two PDF plus one part A PDF, merge all the documents and submit it.
Okay.
Okay.
So how
To
many are there in
understand
your
it.
group? How many are
Yes.
there in your group, Yuvraj?
We are two, sir.
Only two, right?
Yes.
So part A, you'll get one document. Part B, you are getting two documents. Correct? No?
Right. We were thinking of doing part B in a group, but as you suggested, it's not possible. So we'll need to see how we can do it.
Where are you working, Yuvraj?
I'm working in Siemens.
You're not getting single problem statement to solve on BDS. Eh? I have given 20 days of time, guys. You people are not utilizing it. See, these are all last moment answers I'm getting. That's it. Correct? No, Yuvraj. Yes, Ajit, you are unmuting.
No,
Okay.
don't have anything.
So, yes, Saini, you were telling something. Monish Saini, you're asking something.
No, no, it's okay. Actually, in my there are four people actually. So, for example, A, B, C, D. So, if only one person need to submit in Texila, and other people can means should not upload anything, right?
Correct,
Uh,
correct.
on the Texila. Okay.
Yeah. So individually, we will allocate marks after looking at your
After
data.
looking, okay,
Yeah.
fine. So,
For group project, we will see the contribution part. So that's why,
okay,
see, this is my suggestions, guys. In contribution part, you are putting 25% means only 25% of the marks will be allocated to individual person. So involvement, see, 100% involvement is there means you have to mention 100% in the the table. You're not supposed to mention 50% or 75% or 25%. You have to mention 100%. I want each and everyone's involvement in that project. So that's why I've given that column. Okay. So in many cases, so many of them are not responding. So for them, I've given that table. So no one is responding means you please put a 0% there. So they will get 0 marks. Okay. Now you are all getting.
Yes, sir.
Okay.
Yes, sir. And sir, for the lab access, I had raised one request to reset the time because it was showing that terminated. So is
Tushar,
it?
this is
Yeah.
almost done actually. I see
Okay.
I requested them many
Okay.
times.
Oh.
Okay,
Okay.
so this is all done. So don't you have access with other teammates?
Yeah, yeah. I'll use that. Fine.
You use that, okay.
Okay.
See, end moment you people are asking means even I can't react on that, correct? No?
Yeah, actually, yeah, I had raised the ticket, but it came to you very late. Yeah.
Yeah. But see, many of you just asked your friends. So for many, I have suggested them to renew the timings actually. They have done.
Okay.
So is there any questions, guys? No questions
Okay.
means we can stop the session. So start preparing for your examinations, guys. You're all in first semester, right?
Yes.
Yes, sir.
Okay. Okay. Maybe next semester you're going to get COSs. We'll see. Okay. Thank you, guys. That's all from my end. So we'll meet you in next session on session 16. Bye bye. See you. Have a
thank you.
nice. Thank you all.